All right, so starting today's stuff, let's look at real world problems. What was number 8 for Form A people? A radioactive substance, cesium-137, has a half-life of about 30 years. This means that after 30 years, half of the amount of cesium-137 present turns into something else. If the initial amount of cesium-137 was 70 grams, what exponential decay function represents the amount of cesium-137 remaining over time in years? Okay, so this comes from, let me just open up the formula chart where I show you one of these formulas. Formula chart, here we go. Does it use the word exponential? Let me see. Yeah, exponential decay function. So what you would do is you would look for exponential decay, or exponential specifically. So here's exponential function. You'll see that there's two functions. It just says exponential decay. So I'm going to grab, typically if it uses the word continuous or exponentially, you would always go with this, but I'm going to use this one because that's where I'm going to start off with. A equals PERT. I'm using that from the formula chart. This is the exponential. Now, if you were on the test, you'd have multiple choice. I'm just showing you how this gets created. So this says it has a half-life of about 30 years. What that means is that every 30 years, half the amount of cesium present turns into something else. So like if you started with an amount, it tells you if the initial amount is 70. Okay, so question for you, or I guess I'll call it vocabulary. Which letter refers to the initial amount?
P.
P. And so you would have A equals 70 e to the RT. Now, one thing that's tricky on this problem is it says half-life. And we haven't dealt with this much this year, but I'm going to do it now. Just because I don't really like it when they do this, but whenever it says half-life or doubles or something like that for exponential growth or decay, here's what that means. It's telling you e to the power of r, like the exponentially to the power of r equals 1/2. That's what that means when it says half-life. Now, if it said doubled, for example, if it says doubles, what that would mean is that e to the r equals 2. But this says half-life, so it means it equals 1/2. So that's one thing that's not really explained ever in our curriculum, but it showed up once upon a time on one of these ACP exams. And now the district gives it to you as a practice question. So here's what that means. I just changed the equation to look like this. So I first plugged in the initial amount, which was 70, and then e to the r became 1/2. That's what the 1/2 is. When it says the half-life, that's what it means. Now, there's this last little part. It says 30 years. So a lot of people think, oh, so I just put in a 30 there for my answer, but this is going to be incorrect. If you think the formula is this is incorrect, because here's why. This would actually give you an amount. There's no unknown left. And so this says how much remains over time in years. It's going to have like an unknown. So like if we could say how much would be left after 10 years? Well, there's a problem. If you put a t in as 30, you can't solve for 10 years anymore. Or if you said how much is remaining after 5 years? How much is remaining after 100 years? If this was maybe one of the bombs we set off in Hiroshima or Nagasaki, you might say, well, how many years has it been since 46? And well, where do I even put the time in anymore? Because it disappeared. So here's what's tricky about this one is that 30 years, what that means is we take a half every 30 years. So 1/2 every 30. So the way you represent that is time divided by 30. So I would have half of it when t equals 30. If t equals 30, that's 30 divided by 30. You would take half of 70. If t were 60, you would take half of it twice, because 60 divided by 30 is 2. So that's the way this works. That's going to be our formula right here. Now, I know that's kind of tricky. Let's go over the results here. And you'll see that on this problem, the answer choices, how they were written out, did a few things. They tried to put the time in the front, which those were obviously wrong. And you can see that most people got this one correct the first time around. The natural log has nothing to do with exponential, so that would eliminate that one. So this problem, though it was harder in nature about figuring out this stuff, because of that, I think the test makers, whoever made this, it was years ago when I first started teaching pre-cal. I think it was already given as an example question at that time. They tried to make the answer choices at least easier for students, that if you knew the first value was supposed to be initial amount, you should have already been 50-50. And then ln is the inverse of exponential. So it had nothing to do with this problem. Thus, this had to be the answer. But that's what everything refers to. The initial amount is 70. You take half of that whenever your time is 30. So the reason you divide by 30 is after 30 years, you would half it one time. After 60 years, 60 divided by 30 is 2. You would half it twice. After 90 years, you would half it 3 times. That's the concept. So to show you by table, to make this problem go just a little bit longer here, if I opened up Desmos, I'll show you by calculating what this means. Let's just say, well, if it loads, come on now. 70 times 1/2 to the power of x, t, you can use t. T, it won't let me do divide by 30 unless I put a parentheses. T divided by 30 like that. Oh, it won't let me use t. Okay, let's put an x. There we go. And if I change this to table, what you'll notice is that I'm going to start at year 0. At year 0, you have 70. So let's just say the bomb we set off at the end of World War II had 70 grams, which is not true at all. But let's just say it was. What that means is that after, like, say, 1 year, a lot of it's still remaining. But if you know anything about radioactive materials, it slowly starts to disappear. After 30 years, half of it goes away. That's what the half-life means. So if you know your science, after 30 years, half of it's gone. So after 60 years, you would have half of the remaining. After 90 years, you would have half of this value. So it just keeps getting half. So the next one would be like 4.375, I believe, at 120 years, 4.375, yeah, and you keep going. So every 30 years, you'll notice the number just keeps getting cut in half. And so this would be like 1.09375, I think, if I add one more. Yeah, and that's what just keeps happening. So that's the concept on this problem. All right, let's take a look at the next one. And these are a little bit easier when they give you the equation like this. It says the annual growth rate for an investment is found using that function, where R is our annual growth rate, T is the time, P is the initial value of the investment, and P is the present value. 5 years ago. Okay, that's a piece of information. 5 years ago. What is that telling us about the problem?
Or like,
Yeah, you're right on. It's the time. I agree with you. T is the time. So that means T is 5. T equals 5. 5 years ago, Helen invested 5,000. Okay, so next question I have for you is, where does 5,000 go? Is it the current amount or the initial amount? Is it the initial or the present value?
The initial.
Very good, because it says 5 years ago. So we're talking about in the past. This would be the initial, P0. Anytime you have a little 0 with a variable, that means the initial, by the way. At an annual growth rate of 3.7%. Well, so what is 3.7% as far as the equation is concerned? Which letter does that refer to? Only ones we have left are R and P0. ln is not a variable. That's natural log. Is it the R or the P0? I mean, I'm sorry, the P. Yeah, P0. Is it R or P? This 3.7%. Okay, it's the R. So this is R. So if we wanted to solve this, what we could do is just plug in our values. So 3.7%, which I'll get rid of the percent in a second, is equal to 1/5 natural log. We don't know the present value, but we do know the initial value was 5,000. If I solve this in the calculator, I should get the answer. So in solve, if you remember, I have a calculator for that. So instead of just telling you, let's just go click the calculator. In solve is number 1 on our list. And so we type the equation as shown. And by the way, get rid of percent. You divide it by 100%, like that. That gets rid of that. So what I could just do is 3.7 divided by 100 equals 1/5 natural log ln of P divided by 5,000. But the only thing we're going to change is instead of a P, I'm going to put an X. So I'm going to change that to where my unknown is going to be the X. That's what I'm going to do right there. So I have my equation. Now you copy the left side. So you say y equals the left side, and then you have y equals the right side. What that should do is create these different graphs, and wherever they cross, you have your answer. And you should have a vertical line. So if I zoom out, I'll come up, where is my answer going to be? So if I start with $5,000, my idea can be, it's got to be greater than 5,000. So I'm going to scroll out this way. So that's where the answer is going to be. When I click it, it says the answer is $6,016. And since I'm talking money, I'm going to give you the 9 cents as well. So $6,016, $6,016.09 is going to be our answer. Since it was money, I rounded to 2 decimal places. 6016.09. That's our answer. 6016.09. There we go. And that would count. All right, so with insolve, that's how I recommend you solve it, is you do the whole equation and then do y equals the left side and y equals the right side. And that's the instructions here are telling you how to do that. All right, questions over this problem? If you wanted to solve this by hand, which I doubt you do, but just in case, the way you would solve this by hand is first you'd have to get rid of this fraction. Whenever you have a fraction, you want to get rid of it, you multiply by its reciprocal. So instead of, this says multiply by 1, divide by 5. Instead, I would multiply by 5, divide by 1. If you do this on both sides, I believe that's going to be 0.215, I think. Let's check that out. 5 times 0.037. Wow, I'm off. 18.5. 18.5 equals natural log of P over 5,000. And the way you solve a natural log is you convert it to exponential. And so when I convert this, a natural log means the base is E, so it's E, and these two switch. E to the 0.1085 equals P over 5,000. The last step I would do is I would multiply by 5,000. That's, if you want to solve this by hand, that's how you do so. And so if I type this in now, 5,000 times e to the power of 0.185, you get the same answer. Definitely a lot quicker though, just to use Desmos for insolve. And so the next one, it says Matthew and some friends are going to a concert. They hire, before I do this problem, let's see our stats on this one. How do we do overall? Oh, good number. We had 61% get that right. Okay, let's now check this one. Matthew and some friends are going to a concert. They hire a car service for $60 to drive them to a restaurant for dinner and then to a concert. They divide the $90 cost of the dinner equally. However, since Matthew's dad provided concert tickets for the group, the friends agree that Matthew doesn't have to help pay for the car service. The friends divide this cost equally among themselves. If each friend spends a total of $33, how many friends went to the concert with Matthew? Now, we've seen this problem a few times throughout the year. And the key to remembering how to solve this is if you take the total cost and you divide it by the number of people, you get what we call the average cost. Now in this problem, we have two different things going on. We have a car service and we also have dinner. So car service is 60 and dinner is 90. So we have a $60 cost and a $90 cost. And we have an average cost of 33. So there's our money. Now in this problem, if you remember how we did it earlier here, X refers to friends because that's what we're trying to solve. How many friends went with Matthew to the concert? And I'm also going to say 1 equals Matthew. So when it comes to paying for this, it says they divide the $60 concert, or its cost of dinner rather, equally among all of them. So for the dinner, friends and Matthew pay. Friends plus Matthew. But since Matthew's dad gave the friends the tickets for the concert, they don't make him pay for the car. So Matthew doesn't have to pay for the car, only the friends pay for the car. And so that was our equation there that we worked with. Using this same Desmos insolve graph, I'll do the left side over here. So we have 60 divided by friends plus, we have a $90 cost, which was friends plus Matthew, X plus 1. All of that equaled 33. And so over here, you type in the two sides of the equations. Y equals each one of these sides. And I'm going to go back home here to quickly give me in. The vertical lines represent your different answer choices. And so I'll have a negative answer and a positive answer. However, can we have negative friends? Can you have a negative amount of friends? You can have a negative friend personality-wise, but not when you count up how many people. So this one's impossible. The answer is going to be this number here, which it looks like it's 4. If you zoom out to the number that's by itself, which is 33, it's like last problem, I knew that the money had to be greater than 5,000, so I knew where to scroll out. This one, since the number's by itself, the answer is going to be listed at the Y value of 33. If I go there, you'll see there's the number of friends. 4 friends give an average cost of $33. So how many friends went with Matthew to the concert? The answer is 4. This one had, what did I do wrong here? Well, I'm listed as 5. Did I change this problem from what's on my? Okay, so I'm pausing here. I might have just a typo in my, what's it called? My key. So as I look at this, my key is what's wrong. So this one, the answer should be 4. If I typed everything in here correctly, which I think I have, the answer would be 4. So 4 friends. So my stats are incorrect on my other document up here. This would be the correct answer here. So 47 students got this one right. 51 got 5. That was the answer earlier in the year. So my guess is a lot of students just chose the answer from earlier in the year. I probably just changed up the numbers. I've just forgotten what I did on this one. So now let's look on the next problem. So I got a few more of these and then I'll give you a DOL over this. A firework is shot off Actually, this is not the order. Do I have a different order here? Oh, I moved this one. Okay. So I'm going to go on to the next one. I got all off on this order. Hang on a second. Let's find it. Okay. Brent, dealing with blood disorder diabetes, must closely monitor his blood sugar, S of T. After eating a meal, the rise of his blood sugar can be modeled by this equation, where T is time and hours. If his blood sugar needs to remain at a level of 80 or greater, about how much time can Brent wait to eat another meal? So this 80 goes into the equation somewhere. Does 80 refer to S of T or is 80 T? Now it tells you up here, S of T is blood sugar, T is time. So I'm going to underline those. Blood sugar, slide that back over. Blood sugar is S of T, T is time. What is the 80? Is that a blood sugar or a time? All right. The milligrams per deciliter refers to blood sugar. If my blood sugar needs to remain at a level of 80 or higher. So where I'm going to plug this in is for S of T. So the equation we're going to plug in to solve this time is all of that. The 80 equals 7t, negative 7t to the fourth plus 124t cubed minus 320t squared minus 1600t minus 1600. All of that over t squared minus 8t, 8t minus 20. That's what I'm going to plug in here. So it's a long equation here. 80 equals negative 7, or division, negative 7t squared. I'm going to use x though. Plus 124t cubed, x cubed here, minus 320 x squared, minus 1600 x minus 1600. All of this over x squared minus 8x minus 20. Now, if you type this in, it says something about add a slider. What that means is that you have a problem with, you have a t in there as well as an x. So just make sure there shouldn't be any add sliders or anything like that. So I have my equation typed in. And now I go to my second line, and I'm going to say that equals 80. And my third line is going to equal all this right side. So I'll just copy that and paste it right there. So when I look at my picture, I know the answer has to be at 80 because that's the number that's by itself. So I'm going to zoom out just a little bit. I'm actually going to change how I can see this a little better. I want to go here, and I do need to go on the y-axis up to 80, but I'm not really concerned with negative time, and I'm sure I can't go longer than 24 hours without eating. So I'm going to kind of zoom it in like this. So what this is saying is that my blood sugar needs to be 80 or greater. So if you see that, 80 or greater. So it's okay if I'm above 80. So basically I'm looking at, I can be 80 or I could be higher than 80. So those spots there, which that is kind of weird. But this red line is trying to solve. It's the green, that's my blood sugar. As long as my green is above the purple, I'm good. So for all this area, I'm good. Where I start to have problems is right there. Whenever these cross, remember, you can't have a negative answer for time in the real world. So that's impossible. So out of these answer choices, I'm starting at time 0. And then my blood sugar goes up after eating the meal, and then it starts to come down. I can wait until then. If I go and wait longer, I'm in trouble. My blood sugar gets too low. After 0, I'm dead. You can't have a blood sugar of 0. So nothing matters after you get outside the first quadrant in the real world. So I can eliminate all of this. I can eliminate all this. Let me show you what I'm saying. I'm going to eliminate some of the graph. Y is less than or equal to 0. Will that eliminate? Yes, that eliminates. I'm going to say x is less than or equal to 0. So this part of the graph needs, you don't pay attention to that part. That's outside the first quadrant. So I'm only looking at this area, and I need the part where the graph is above this purple line. I can stop paying attention to the graph right there. Nothing matters anymore. So I don't have to pay attention to this part either. So I could say y is greater than or equal to, not y, x. That would eliminate that portion. So you're just looking from there to there. That's the window of time that I can survive and have my blood sugar in a good area. So the answer to this problem would be 7.283 hours. 7.283 hours is how long I can wait. All right, and before I move on to that one, I'm going to finish with this firework problem. It says a firework is shot off the ground with an initial velocity of 33 feet per second. Pause. Let's see how we do in that problem. 40% got that right. All right. I don't know where the firework problem is. What do I do with that one? I'll have to figure out where the firework problem is, but we're going to do the firework right now. It's shot off the ground with an initial velocity of 33 feet per second. The height of the firework, actually, I know why it's on there. I had a typo on this one, and I fixed it on this. There it is. I knew I did that. I did this at the very end. This is actually the problem we're going to look at. It was supposed to be 133. So when you tested, you actually had it right. When I fixed it, it shifted it way down to the bottom, but I haven't updated this form. This needs to be a 1. That's why it was out of order. Okay, firework is shot off the ground with an initial velocity of 133 feet per second. The height of the firework in feet varies with time and is given by this function, where g is 32 feet per second, t is the time, v0 is the initial velocity, and h0 is the initial height. What is the maximum height of the firework rounded to the nearest foot? Okay, so let's plug stuff in. It tells me by g. That's good. It tells me my initial velocity. According to the problem, v0 is initial velocity. It said, there's a very important statement, the very first sentence. The firework is shot off the ground. Off the ground is telling you something about the problem. It's telling you about your initial height. If it's shot off the ground, what's the initial height?
0.
Very good. So we can plug in our values here. They don't give me anything about the height after we take off, so it'll be h of t equals -1/2. G is 32. We don't know anything about the time either. Plus 133, the v0, t plus 0. That's my equation. And it wants to know the maximum height. So here in this, what I'm gonna do here, let me clear this because I added so much stuff to it. Just gonna get a new blank graph. So here's the original problem, and I'll take away the t in a little bit, okay? Just bear with me for a second. -1/2 times 32 t squared plus 133 t plus 0. So here's the graph. The reason this one graphed is because at the front I was able to say h of t. If I wasn't able to put the t there, for example, if I had an x, we would have problems. So it does work if you have all t's. If you don't like that, just make them all x's. And it'll work just fine that way too. So now I have it as all x's, and it works that way. I want to know the maximum height. So the maximum height would be the highest point. If I go out here and I just keep zooming up, I'll find the maximum height. And on Desmos, all you have to do is click it. So it doesn't matter which graph you had, the maximum height's right there. So you have a 4.156 and you have a 2.76.319. So that's where the maximum occurs. maximum point, let me do it that way. The maximum point was 4 point, scroll this over, see if I can see it. 156. And the y value is 276.391. This wants to know the maximum height. So is height X word or a Y word? Meaning is height horizontal or is height vertical?
It's a Y word.
That's right. Height wants to know the Y value. So the correct answer is going to be this value. That's the Y value. And since I'm looking for, it says to the nearest foot, this would round down, so it'd be 276 is the answer. 276. And let's see how we did on the actual test. Only 2 students got that right. 133 other students either did not do it or got something else, but 276 was the correct answer. So only 2 students out of all of them got this one right. So because of that, now I have your first few DOLs. We've done quite a few problems. I've given you DOLs built off of this problem. So if you open up and go to number 5, I have 2 different questions. They're both free response. I have the same equation, but I've changed the value. And I want you to find the maximum height and how long would it take for the remnants of the firework to return to the ground. So return to the ground obviously means how long does it take to hit the ground? And with the how long, you need to think about, is that a height or is that a time? But you'll do it with this other problem there. Okay, so those are the values you'd be looking for. You're either looking for the top there, whoops. Why is it, I wanted to zoom out just a little further. Okay, you'll either look for the maximum or where it hits the ground. That's where it goes up, that's where it hits the ground. All right, I'll give you a few moments to do this DOL.
You used the blank graph, right?
Yes, I would just use a blank graph.